So these are the solutions to the quiz at the end of lesson 2.1. So let's start with the first question. Electrical potential energy is, and it is the work done by the field moving from R to infinity. That's just referring back to the lesson material at the beginning of the lesson. Number 2, electrical potential is the same thing as potential energy. No, it's not an energy. Potential energy per unit of charge. And yes, that is what it is. It's not force per unit of charge, and it's not charge per unit of force. So, number 3, which one of the following statements is false? No work required to move along an equipotential surface. True. Electric field is zero everywhere inside a conductor. Also true, because the charges will distribute themselves so that is true. If the potential within a region is zero, the field must also be zero, and that is also true. But the electric field is never perpendicular to equipotential surfaces, and in fact that is always true. So D is the correct one there. And then number 4, we've got electrical potential energy at a certain point is 12 volts. And we have a charge of -3 millicoulombs. So we know that we have to work out the electrical potential energy. So we're after U, which is V times Q, will be 12 times -3 by 10 to the -3. We have -36 by 10 to the -3 joules, or -36 millijoules. And to be sure about the charge, we've got the potential around a positive charge, and so we have positive potential, but we have a negative charge there. So it is a negative energy, and so that is D. Now number 5, the work done to move a charge that is plus 0.25 coulombs from A to B, and the work to do that is plus 175 joules. What is the potential difference between the 2 points? So we know that the potential difference is just the potential energy per unit of charge. It is 175 over 0.25. So that is 700 volts, and we have raised its potential because we've done positive work on it to raise its potential energy. Number 6, we have a proton, so the charge is plus 1.602 by 10 to the -19 coulombs. And we want to know what work would the field do moving the proton from a point with V is plus 25 volts to a point where it is plus 55 volts. So the change in potential is it has gone down by 70 volts. So the work done is Q times change in potential, 1.602 by 10 to the -19 times 70 being the change in potential, and we have 1.12 by 10 to the -17 joules. And so the field has done positive work because that is where the proton wants to go. How would the answer change if it was an electron? Then the answer would be minus 1.12 by 10 to the -17 joules, just meaning that that would be the field doing negative work. And finally, question 7. we have 2 point charges. Each of them is -2 nanocoulombs. And we have a distance of 0.1 in between them, and then we have a point P here that is a distance of 0.15 from, I'm going to label that charge 1, and that is charge 2, so that we have R1 is going to be 0.1 plus 0.15, so that's 0.25, and then we have R2 is 0.15. So the potential will be the potential due to 0.1 plus the potential due to 0.2, which will be Q, which is, they've both got the same charge, over 4 pi E naught R1 plus Q over 4 pi E naught R2. So we have minus 2 by 10 to the minus 9, 4 pi times 8.854 by 10 to the minus 12, 1 over 0.25 plus 1 over 0.15. So I've just taken all the constant terms out the front. That will be minus, once I've simply worked all that out, 1.92 by 10 to the 2 volts, or minus 192 volts.